Before I do this example, I always have a student, not always, one semester I had a student that got mad at me for this example, okay? Um, so again, this is just statistically speaking. I am not considering luck, spirituality, prayers, anything. This is straight statistically speaking, okay? I had a student get mad at me. I'm not even lying. Okay. Um, Now, somebody will have to help me because I can't even remember if I'm accurate with this, with the Florida Lotto. How many numbers do you get to choose from? Is it 53? Does anybody play? If we don't remember, I'm just going to make it up. Does anybody remember? Okay, it's okay. Obviously, we all don't play. So nobody's going to get mad at me this time. Okay. Whatever, I'm just going to say blank lotto, okay, because it's obviously not Florida. The blank lotto, whatever state it is, has a total number, a total of, let me say, 53 numbers to choose from. You win the jackpot if you select the correct 6 numbers from the 53 total. Oops, sorry. Sorry. Okay. Yeah, the blank lotto has a total of 53 numbers to choose from. You win the jackpot if you select the correct 6 numbers from the 53 total. But you do not have to select them in the same order, or in the correct order, I should say. So let's call this part A. What is, the probability of winning the jackpot? Okay, let's do part A first. I think it's 53 in Florida. I'm not sure. Wish I kind of just go sometimes and just do a quick pick, whatever. That's just me, like, okay, I might be lucky today. I haven't been lucky yet. Maybe one day I will be. We'll see. But anyway, some place has a lottery that has a total of 53 numbers to choose from. You win the jackpot if you select the correct 6 numbers from that 53 total, but you do not have to select them in the correct order to win. What is the probability of winning that jackpot? First things first. I need to figure out, because I don't know, only one of those numbers, or one of those, 6 numbers, one of those selections is correct. But I need to know how many total ways I can select, 6 numbers from 53 total. I don't know that. So I have to figure out the total amount. So that's what this is about. Now, I think in my head, I go, well, I'm selecting a piece of a total, right? That's what it sounds like to me. I'm not selecting all 53 and arranging them. I'm selecting 6. So that sounds like one of these rules. It could either be permutations or combinations where, what's in this case? N in this case is what? Total 53. And R in this case is how many? I'm selecting 6. Now, the question is, does order matter? Well, somebody tell me. Somebody, I think Ernie said. No, order does not matter. I win if I select the correct 6 numbers, whether or not they're in the same order that they selected. So I'm going to win if I select the 6, period. Order does not matter. So it does not matter. So I'm selecting a piece of a total. Order doesn't matter. So boom, combinations. So let's see, here's my total amount of ways I could do this. So 53, C, 6, right? So I'm going to use my calculator to do that. I could do that with the, I could do it with the formula if I want to. Let's do my calculator. 53C6. So what do? I go 53. I'm going to go to math. Scroll over to prob. That's where it is. Number 3 here. NCR, and then 6. And let's see how many total ways I could do that. 2, blah, blah, blah. That number. 22 million, something. So I have So 22,957,480. So 22,957,480 different ways that I could select 6 numbers from 53 where order does not matter. So the probability of me winning the jackpot, how many out of those is the actual winning jackpot? 1. I'm only buying 1 ticket, by the way. 1 out of 22,957,480. Now let me see what that is in decimal form. And this is where my student got mad at me. They got mad at me because they saw this probability and I said this is highly unlikely. Because when I go ahead and I do this in my calculator, I get approximately 4.356 times 10 to the negative 8, which is 0.1234567 blah. That, which in a percentage form, move the decimal 2 places to the right. So I have 1, 2, 3, 4, 5 zeros left. 1, 2, 3, 4, 5, 4, 3, 5, 6%. Again, I am not considering luck. I am not considering prayer. I am not considering anything like that. This is straight statistically speaking. And statistics we say if the probability is less than 5%, it is unlikely. I would say that this is highly unlikely. However, people do win. So, all right, why do they? Maybe they buy more than 1 ticket. What would I do if I bought more than 1 ticket? What would change? I would raise it to an exponent. So what am I going to change this time? I want to now see what the probability of winning the jackpot is if I select them. I have to now, but you do have to, I'm just going to say, but you have to select them in the correct order. Now, you guys tell me what changes. I still am selecting a piece of the total. I still want to determine like total amount because I want to know the probability of winning. But obviously what changes? Instead of combinations, now order matters. So now I have to not only select the right 6 numbers, I have to select them in the correct order. Otherwise I don't win. So permutations, right? Before I do permutations, while I write this down, I want you guys to think. Do you think that I'll have more total outcomes or less? Will I have more total outcomes or less? This time order matters. Now, this is typical. So permutations, right? Permutations. This is, I get a typical answer. Somebody said less. I typically get that. Every semester somebody's telling me less. I say more. There are more outcomes. Why? Because not only does 1, 2, 3, 4, 5, 6 represent one possible outcome, 6, 5, 4, 3, 2, 1 also represents a separate outcome. Versus with combinations, the order in which it comes does not matter. 1, 2, 3, 4, 5, 6 would be the same as 6, 5, 4, 3, 2, 1. Because as long as I select the right 6 numbers, I win. Here, I have to select them in the correct order. So there's going to be a lot more outcomes. Let's see. 53, P, 6. Let's do permutations. You guys go ahead and do it. So 53, permutations, 6. My calculator says 1.653. 1.653 times 10 to the 10th. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Approximately. Okay, I'm rounding obviously because there are multiple digits in that. 16,500,000,000. And the probability of winning, how many out of that is the winning number? So am I expecting my probability to be higher or lower? Is it more likely or less likely for me to win this? By randomly guessing and all that random stuff. 6.05 times 10 to the negative 11. 0. I'm not gonna. I did this. This is maybe why she got mad at me because I said, you know what? I'm gonna show you the number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 6, 1. I'm not even gonna do that in percentage form, okay? Obviously, it's less likely if you think about it, right? I have more possible outcomes. So 1 out of that is going to be, so as the denominator increases, the whole fraction decreases, right? So this is, of course,